Hi, Joe Cerrone.
And Al Rosen.
Welcome to CAD-107. We're giving our video lecture for our Zoom meeting number 3 today. We've gone through and recorded the lecture for Chapter 2 from the textbook. Chapter 2 is on filaments and materials and different types of 3D printers. And so if you click on the video lecture, it's a little farther ahead here. Let's back it up a little bit. Al and I go through 3D printers and printable materials, and essentially we talk about how that relates to what we're doing in the class and to our projects. So that video is available in D2L, and it basically covers Chapter 2 of the 3D printing textbook. We've released the lab number 3 assignment, which is this stationary holder. We have a video on how to do the lab on YouTube with AutoCAD. It's pretty straightforward. You'll need this B-size metric sheet of paper. And if we take a look at these other links, this link right here is for students who may have any trouble getting the software to run. It's that point now where we're a couple of weeks into the course and people are starting to have difficulty with technology. And if you are, just make sure you contact us and we'll see if we can help you get through that. The project is located here from the textbook. Again, we're working on these projects in the mechanical design CAD department. And so we will go through and show how to model these with CAD. And then next week, we'll start going through and slicing them and printing them. And so as we look at this, basically a pencil or pen holder, I would call it a pen holder, not a stationary holder. They create these diameter values, just circles essentially, and they're all kind of touching each other. They have this little area where they joined them on the bottom. When I did this project on AutoCAD, I just put like a little base along the bottom and extruded it. And so I'll walk you through how to go through and do that. I've actually added a little Oakton logo to it. We like to kind of brand our projects. It's kind of fun. And so that's another aspect of this week's lab assignment. And so it's in millimeters, gives the heights of these different kind of towers and then the modeling techniques. So he added these little details to hold everything together. I just put a pad on the bottom and it's kind of nice. You can actually have something like that on your desk and design and build. Back to the home page, a review of what we've been up to. Here's last week's meeting where we went through and made these tags, you know, backpack tags or tags that you could use for name tag. If I were to look at the Dremel 3D printer, here's Al Rosen's instructor. And then if I look at the actual printer, I've got the networking all set up and working. You can see we've got a 3D print. Here's the filament, here's our Bowden tube, and it kind of goes into our printer head. So as we get farther along the course, we'll start to do more hands-on demos. It's really a neat device because they actually have this cloud printing. And if everything is working right, I get the little Dremel DigiLab cloud. It's a little cloud that shows up on the panel. And I can then take things from my phone or any place remotely and download them to the printer and print them. So very cool stuff as far as being able to work remotely with these printers. We went through lab 2 last week. Lab 2 is this do not disturb sign. Essentially, we did it with AutoCAD and we also did it with SolidWorks. So students can start to choose which software they want to use. We mostly lead with AutoCAD because we have more people with those skills, but SolidWorks is an excellent tool for that as well. All right, so that's sort of the recap. If we go through and we take a look at the module for our stationary holder, we can go here to content. and we can go to lab 3, it maps to the book as project 9. And so that's why we put that the way that is there. Here's the document. Here's the drawing so that the students can download it, open it, and go through some of the modeling steps. And so as we look at this project, I've gone through, and yeah, you could say you could just use my file, but I would know. I really want to make this to a point where it's sort of bulletproof. And so if I change the view to a top view, you can kind of see my thought process on this. The basic thought was to draw these different circular shapes with these different diameters, 30 millimeters, 25 millimeters. And those relate to the way that they are in the textbook. And so if we look at the file, let's see. Let me know if that's not showing up, Al.
It's working fine.
Great. So the stationary holder is designed, again, you know, we're using CAD to be able to do that. Instead of using cylinders or circles, hexagon shapes, and I kind of changed the design as I went through and did it. And I'll show you how I did that. Here's the diameters in millimeters, and then the heights for those. So if we go back and take a look at the file, I just created these circular shapes, and then I just put a rectangle around it. I created a video that shows how to do this, and so we don't have to go through every exact step. Then I created polygons that go around it, and to do that, I would go over to the polygon command. Polygon. And then you could say number of sides. And so let's say 6 sides, center of the polygon. I'll turn on my OSNAP, and I'll hover, acquire that. Circumscribe means it goes around the outside. And so I can create that shape like that. And then we can do the same for some of these others. You're welcome to change the colors. And another polygon, hover, 6 sides, center of the polygon right there, circumscribed. And so we create these different polygon shapes like that. And you can just use circles if you want and offset those. And so here I have that. And then what I've done here is I've offset those, the thickness that he's recommending in the assignment. And so if we come back here and we look at it on these thicknesses somewhere in here, I think he's calling it a 5 millimeter thickness. So he didn't exactly say, but I would say if I come back here and I look at it, I can always measure it. And so if I wanted to measure it, I could go from here to here. It doesn't work that way. So let's just try a measure distance. And so we'll go from here. Yeah, 5 millimeters. And so you can offset those 5 millimeters, and then you can take those and you can press pull them into the shape, or you can extrude them. And so if we were to extrude them, and let's take a look at that height, 130 millimeters, I could come over here and I could say extrude. Let's try press pull. It's easier, but it sometimes fails. So if I come in here, click there we go. And then we can pull this up 150 millimeters. And you can make these different heights. You have to get the area right in between these to get this to properly press pull. And then we can go and set up the different heights for these different objects. And so once you have those modeled in 3D, what I did was I put a border around the bottom, and then I extruded that. And I extruded it in the vertical up direction, positive Z, so that they actually intersect with the bottom of the base by going again with extrude. And then pulling that up. And if we wanted to extrude that in, let's say, this color, I could say extrude, select it, hit enter, and then pull that up, maybe 5 millimeters. And then what I did here was to union these parts so that they're all one piece. And so I went and I said union. And then I branded it, and you can look at how to add a logo brand in the video tutorial. Not required, but it's kind of fun. It's kind of neat. Once we have the part modeled, save the file, save it as your initials -lab 3. I think I have this one as project 9, but if I say save as, we'll save that to our directory.
And don't forget to put into the Dropbox / assignment box, please.
Right, we would like the drawing files and the STL files. And so once you have the drawing file, what you'll do is you'll go to D2L and you'll go to, let's go to Student View, Assignments, Lab 3. It gives you the rubric, how that will be graded. And then we can go and we can add a file and upload our project. And we can add that. If you have any messages, you could say, you know,
If you're not too sure of drawing it, it's not complete yet, and you want us to take a look at it before we grade it, you put it in there, put in information, and what do you want us to do, what do we want to see, and we'll get back to you one way or another.
So you can always ask questions there at that point. So I'm not sure if it'll let me submit it. I'll give it a shot. I guess it did. All right, let's get back out of student view and then get back to the part itself. We'll keep this video relatively short. I'll just go a couple more minutes. So once you have the part modeled, and I'm gonna export the one with the Oakton logo on it. So I'm gonna say export, other format, and dial in the STL lithography file. And this will be JC Lab 3. I'll click on it. I'll hit enter. And that's it. It does that, and we can then go into the slicing software. And this is the Dremel DigiSlicer that the instructions on how to download it are in the main splash page. But what I can do is I can erase this, and then I can open my file. The STL file. I'll open it. And then I'm going to place it. Whoops. I need to have it set for move. And I'll place it on the palette. Hopefully it'll fit. Now it's a little big apparently. And so I may have to scale this down just slightly. And so what I'll do is I'll go to the scale factor and I'll bring this down, let's say 80%. And then we'll pull this, whoops. into the middle of the part. And when it does that, when it's no longer got those zebra stripes on it, it's ready to go. And so if we wanted to slice this, we could go in here and we would tell it we want PLA. We can dial in the quality level of that part. And at this point, there's not a whole lot of things that we're going to go and change on it. As we start to get better with CAD and we start seeing more of the CAD assignments come in there, we'll be able to work with this. We're not going to need to generate support because all of this is vertically orientated. There's not any overhangs. And so that'll not be required, which will save us some time. And I'll just prepare it. And then that'll tell me that this is a 7-hour print job. So the jobs take quite a while when they're large like this. If we want to view the layers, we can go through and then take a look at how this part will be built up, layer by layer. And then since I've got a part in there right now, I really can't go through and build it until I take this part out and then swap it out. But it's really pretty tech savvy when you get down to it. They have these cameras inside the machines, so I could watch it on my phone. And then if I do have a failure, I can stop the print. And the other side of it too is if I have somebody at the house who can put in a pallet, or at the lab, you can work remotely and say, I'm going to send in my file and send it to the printer. So some really neat stuff with the Dremel Print Cloud. Okay, that's a wrap on today's assignment. Make sure that you go through and you turn in the projects to the Dropbox. Make sure that you go through and you do any of the quizzes and exams. So there's one quiz and exam, review questions from chapter 1, and we'll post a second review questions from chapter 2 this week, and you'll be responsible for answering those questions as well. All right, Al, is there anything that I need to cover that I have missed?
Nope, just keep us informed if you need anything or need some help on something. When you send us an email, make sure, or text to us, make sure you put down your name and also the class you're in. And this class is a 107 class, CAD-107, so we know where to look to.
Sounds good. So again, if you have any difficulty, email us. Otherwise, we're going to call it a day for this lecture, and I'm going to end the meeting, end the recording.